So today in class we did questions where we graphed parabolas and found where they crossed the x-axis. So we were working with the x-intercepts. Today we're going to take a look at using the graphing calculator to achieve that same type of success. And you'll see why the graphing calculator is handy for some of these questions compared to doing it by hand. So we're going to start by doing this question by graphing it by hand, and I'm actually going to change this equation to y equals x squared minus 4x minus 1. So this is in standard form. Remember, in standard form we have an a value, we have a b value, and we have a c value. So a is the number in front of x squared, b is the number in front of x, and c is the constant that doesn't have a variable with it. And it's important to identify those because when the equation's in standard form, the shortcut for finding the vertex is using the little formula. So if I use the little formula here, minus b means change the sign of b. So if I change the sign of b, that becomes 4. 2 times a, so it's going to be 2 times 1. That's just going to give me 4 over 2, which is equal to 2. So the x value in the vertex is 2. Now I'm going to sub that in to my equation. So when I sub that into the equation, I'll get 4 minus 8 minus 1. So I get y is equal to minus 5. So the vertex for this parabola is 2, negative 5. And if I look up in front of the x squared here to figure out the step pattern, I realize that the step pattern is just the normal 1, 3, 5 step pattern. So if I plot those on the graph, that information, so I go to 2, negative 5. That's where my vertex goes. And then I'll count the step pattern from there. It is opening up, so I'm going to step over 1 and up 1, over 1 and up 3, over 1 and up 1, 2, 3, 4, 5. And then I've got the mirror points on the other side of the vertex because of the symmetry. So it's going to look like that. I'll sketch the curve here through these points. So it's going to look like that. So I graphed it. Now I have to state the x-intercepts. So the x-intercepts are equal to, now the problem is that the x-intercepts don't go through exact points here. So we're kind of estimating. So the one on the left I might estimate as negative 0.2. And the one on the right I might estimate to be 4.3. Okay? So I summarized this in the paragraph below, but basically in a situation like this, the x-intercept has to be estimated. So it's not very accurate if the parabola doesn't go through an actual integer on the x-axis. The graphing calculator has a built-in function for finding the x-intercepts of a function. So it's going to be much more accurate for us to use the graphing calculator to help find the x-intercepts. One thing I need you to remember too is that we call these the x-intercepts, or they'll also be referred to as the roots of the equation, or they may also be called the zeros of the function. So those three words are all interchangeable when it comes to talking about the x-intercepts. All right, so let's say that we get an equation like this that says find the roots of this equation here. So it's a quadratic equation because the x is squared in it, so we can't isolate the x. We're going to rearrange it and make one side equal to 0. So in order to rearrange things here, I'm going to move the minus 9x and the 10 to the other side. The 40x squared is already positive, so I'll leave it as 40x squared, and then the x term will come next, so plus 9x, and then minus 10, and that'll be equal to 0. 0 will be left on the right-hand side. So the parabola that we want to graph to find the x-intercepts is we want to graph y equals 40x squared plus 9x and minus 10. So to do that, and these steps are on your note there, and you're going to be able to use the graphing calculator tomorrow in class, but you can follow along with what I'm doing here. So if I turn this on, there we go. There we go. Okay. So first thing I want to do is I want to go to the y equals button, and it's on the top left of the buttons on the calculator. So if I hit y equals, I get this screen here, and I'm going to type in the 40x squared plus 9x minus 10. So I punch in 40. To get x, I punch the button beside the green button, so 40x. I'm just going to hit the x squared button to square that, and then I'm going to have plus, and then 9x, so 9, and the button beside the green button, and then subtract 10. And subtract is the blue button, so it's going to look like that. Okay? And if I hit graph, you can see that I get the same graph that we have here. And it's not really ideal. We can't really see what's going on with the graph. So I can change the window setting so that it looks a little bit nicer. It's easier to see what's going on. So beside the y equals button on the graphing calculator is the button that says window. And I'm going to change it so that on my original graph it goes from negative 10 to positive 10. I really only need to go from negative 2 to positive 2 probably. So I'm going to change this to negative 2. And when you punch in that negative there, for that negative 2, you have to use that button on the calculator in white. That's the negative button. So be careful you don't use the subtract button. So for the x values, I'm going from negative 2 to positive 2. And I'll leave the scale as 1. And you can see that the bottom of my parabola here, we almost don't quite see. So I'm going to move the y minimum down a little bit so I've got room there. So I'm going to make the y minimum negative 12. And we'll go up to 10 is good. And we'll leave everything else. And now when I hit graph, I get this graph here. So you can see that the x-intercepts are, this one's a little bit, so I've got this one here that's in between 0 and negative 1, and I've got this one here that's between 0 and 1. So this is where the graphing calculator is a big help to find those decimal x-intercepts. So the next step that I have to follow here is, in those top blue buttons on the calculator, you can see the button trace. So I'm going to punch, I need to get to the calc menu, which is the calculate thing. So I'm going to hit second and trace, and that takes me to the calculate menu like on your page. And I need to find the 0. So I'm going to hit number 2, or I can move down to the 2 and hit enter. Okay, so you can see my equation for my parabola is here, and then it says something about left bound x equals 0, y equals -10. Okay, what I'm going to do now is, you can see the flashing point on my graph at that point. I'm going to move that so that it is to the left. Well, let's move it up to where that x-intercept is on the left. So I'm going to move it up to about there. Okay? And the calculator, it's going to help us narrow down where the x-intercept is there. It's not right at negative 0.638 and so on there. I'm going to move a couple of spots to the left of that, and I'm going to press enter. So I'm basically making a mark that's a little bit to the left of that first x-intercept. So I hit enter. Now I have to do right bound. So for right bound, I need to move a couple spots past the where the x-intercept is, and I'm going to hit enter on that. And then it says guess. And for guess, I'm going to move back to, whoops, I'll hit my left cursor arrow, and I move back to close to where that x-intercept is located. Okay, so I've gone through these steps. Let me just move to the next page here. Now it asks for a guess. So for the guess part, I move it close to the x-intercept, and now I just push enter. And what it does is it displays what that intercept is. So you can see on my calculator and on your screenshot there on your page, the first 0 there is negative 0.625. Now we're going to do the exact same thing for the other x-intercept. So I'm going to do second trace. I'm going to hit the 0, and this time I'm going to move my right cursor over, and it's asking for left bound. Okay, there's around where the intercept is. So I'm going to move a couple to the left of that, a couple of hits of the cursor, and I'm going to hit enter. That's going to be my left bound. And then I need to move to the right of that point, so I'll move a couple past it to the right, and I'll hit enter. And now it's asking for the guess. So I'm going to go close to where that point is, and I'm going to hit enter, and I get 0.4 for that one. So if I call up the calculator there again, you can see I get 0.4 just like I did here. So that means that the roots, or the zeros, or the x-intercepts for that equation, to solve that equation, those are the values of x, 0.4 and negative 0.625. So you can see that when we drew that first graph in the note, it was difficult to figure out what the intercepts actually were. We had to estimate. But with the graphing calculator, it gives us the exact value of the x-intercept. So we'll do some work in class tomorrow using the graphing calculator so you get used to that. Have a great day.